Hey everyone, welcome back to the channel. Look around you right now. Chances are you're looking through a window at your phone screen, or maybe you have a glass of water nearby. Glass is so fundamental to our modern lives that we barely even notice it. But have you ever stopped to think about how this incredible material is made? People have been making glass for thousands of years, refining a magical process that transforms one of the most common things on Earth, sand, into the transparent wonder we rely on every single day. So, how exactly do we turn humble grains of sand into crystal clear glass? Stick around, because we're about to dive into the fiery, fascinating world of glassmaking. So, what's the secret recipe for glass? The star ingredient, making up about 75% of the mix, is something called silica sand. But this isn't the same sand you'd find at the beach. It's a special, high-purity type of sand, chemically known as silicon dioxide, or CO2. On its own, silica sand has an incredibly high melting point, over 2,000 degrees Celsius. To make the process more manageable and energy efficient, we add a couple of key ingredients. First is soda ash, or sodium carbonate. This acts as a flux, dramatically lowering the melting temperature to around 1,700 degrees Celsius. Next, we add limestone, which is calcium carbonate. This is the stabilizer. Without it, the final glass would actually dissolve in water over time. These three ingredients, silica, soda ash, and limestone, form the backbone of most common glass. But what if you want colored glass? That's where optional ingredients come in. Small amounts of different metal oxides can create a rainbow of colors. For instance, adding a little bit of iron will give you that classic green tint you see in many bottles. A touch of cobalt creates a brilliant deep blue, while adding sulfur can result in shades from yellow to amber. It's amazing how these tiny additions can completely change the final appearance of the glass. It's a true science, almost like baking a cake, where every single ingredient has a specific purpose and must be measured perfectly. Speaking of recipes, once all the raw materials are gathered, the next step is mixing them all together. This isn't just a matter of throwing everything into a bucket and giving it a stir. The ingredients are weighed with extreme precision because the ratio has to be perfect to get the desired properties in the final product. A slight error in the measurements could lead to glass that's too brittle, cloudy, or has other defects. Once measured, the raw materials are thoroughly mixed to create a uniform batch. And here's a cool sustainability fact. This is where recycled glass comes in. Crushed, recycled glass, known as cullet, is often added to the mix. Cullet is a fantastic addition because it melts at a lower temperature than the raw materials, which means the furnace doesn't have to work as hard. This saves a significant amount of energy, reduces carbon emissions, and lessens the need for quarrying new raw materials. It's a win-win for both the manufacturer and the environment. Now, we get to the heart of the process, literally. The carefully mixed batch is fed into a massive furnace, a blazing inferno that can run 24 hours a day, 7 days a week, sometimes for years at a time. Inside this furnace, the temperature reaches a staggering 1,700 degrees Celsius, or about 3,090 degrees Fahrenheit. That's hotter than volcanic lava. At this intense heat, the solid ingredients, the sand, the soda ash, the limestone, and the cullet, all begin to melt, break down, and fuse together. As the batch liquefies, it transforms into a thick, glowing, honey-like substance, molten glass. It's a mesmerizing sight, a vibrant, orange-red river of liquid fire. The mixture is kept at this extreme temperature for some time to ensure everything is completely melted and to allow bubbles to escape, resulting in a smooth, uniform liquid ready for the next stage, shaping. Once we have our pot of glowing, molten glass, it's time to give it a shape. And there are a few amazing ways to do this. For the massive, perfectly flat sheets of glass used in windows and skyscrapers, manufacturers use the float process. In this method, the molten glass is poured from the furnace onto a bed of molten tin. Because the glass is lighter than the tin, it floats on top, spreading out to form a perfectly flat, uniform sheet. It's an ingenious way to get that flawless surface we take for granted. For things like bottles and jars, the blowing process is used. A blob of molten glass is gathered on the end of a pipe, and air is blown into it, either by a person or a machine, to inflate it like a balloon inside a mold. This creates the hollow shape we're all familiar with. Finally, For more intricate designs, like decorative glassware or car headlights, pressing or molding is used. Molten glass is pressed into a pre-shaped mold to create the desired form. Each method is a marvel of engineering, designed to shape this fiery liquid into a useful, solid object. After the glass has been shaped, it might look finished, but it's hiding a lot of internal stress. If it were cooled down too quickly, it would shatter into a million pieces. To prevent this, the newly formed glass must go through a crucial step called annealing. The glass is moved onto a conveyor belt that takes it through a long, tunnel-like oven called an annealing layer. Inside the layer, the temperature is carefully controlled. It starts out hot and then gradually, very slowly, cools down over a specific period of time. This controlled cooling process allows the glass molecules to settle into a stable, relaxed structure, relieving all those internal stresses. It's a bit like a cool-down stretch after a workout. It prevents injury and ensures the final product is strong and durable. Without annealing, almost every piece of glass we use would be incredibly fragile and unsafe. Once the glass has been annealed and has cooled to room temperature, it's almost ready. The large sheets of float glass emerge from the layer in a continuous ribbon, which is then automatically cut to standard sizes. Highly sensitive scanners and quality control inspectors check every inch of the glass for any imperfections, like bubbles, scratches, or distortions. Only the highest quality pieces make it to the next step. For some applications, the glass undergoes further processing. For example, it might be tempered to make it stronger and safer. Tempering involves reheating the glass and then rapidly cooling its surface, which creates a tough outer layer. If tempered glass does break, it shatters into small, blunt pebbles instead of sharp shards. Other treatments include applying special coatings for insulation, UV protection, or to create a mirrored surface. It's this finishing touch that customizes the glass for its final purpose. Finally, let's talk about the beautiful circular journey of glass. One of the best things about it is that it's 100% recyclable. Any waste glass from the manufacturing process, or the glass bottles and jars you put in your recycling bin, can be crushed into cullet and melted down to make new glass. And unlike some other materials, glass can be recycled over and over again without any loss in quality or purity. As we mentioned earlier, using cullet saves a massive amount of energy compared to starting from raw materials. It also reduces the need to mine for more sand and limestone, preserving our natural landscapes. So, every time you recycle a glass bottle, you're directly contributing to a more sustainable manufacturing process, saving energy and reducing waste. It's a simple action with a huge impact. So there you have it. From simple sand to a molten, fiery liquid, and finally, into a perfectly clear, solid, and incredibly useful material. The process combines intense heat, precise chemistry, and brilliant engineering to create something we use in every aspect of our lives. It's a testament to human ingenuity that has been perfected over thousands of years. The next time you look through a window, swipe on your smartphone, or sip from a glass, take a moment to appreciate the journey it took. You're not just looking at a piece of glass. You're seeing science, heat, and craftsmanship perfectly combined. Thanks so much for watching. If you found this journey into the world of glassmaking interesting, please give this video a thumbs up and hit that subscribe button for more deep dives into how things are made. And don't forget to ring the notification bell so you never miss an episode. We'll see you in the next one.